2009 Grade 11 Hypatia Math Contest. Number 1. Emma counts the number of students in her class with each eye and hair color and summarizes the results in the following table. What percentage of the students have both green eyes and brown hair? So basically what they're saying in this part is look at the table and look at who has green eyes and brown hair, and that would be 2 in terms of the number of students. And then they want a percentage, so don't forget what they're asking. So if you count all these up, there's 20 students in total. So the percentage would be 2 over 20, and that's of course 10%. Part B, what percentage of the students have green eyes or brown hair or both? So let's first count how many have green eyes. So that would be this column, so 2 plus 4 plus 8, so that's, 2 plus 4 plus 2, so that's 8. And then let's count that column that has, this one, brown hair. So that's 3 plus 2 plus 2, so that's 7. But be careful because though we've double counted green eyes and brown hair twice. So these guys we've double counted, so we have to subtract 2. So that would give me 13. And then, of course, as before, we have to figure out the percentage. There's a total of 20 students in the class, so it'd be 13 over 20, which is 65%. Part C. Of the students who have green eyes, what percentage also have red hair? So how many students have green eyes? You're looking at this row, so that's 2 plus 4 plus 2, so that's 8. And how many have red hair? Well, just those 2, so 2 out of the 8, and that's 25%. D, determine how many students with red hair must join the class so that the percentage of students in the class with red hair becomes 36%. All right, so part D, we have initially 20 students, and we're going to add some students that have red hair, so I'll denote that as R. And then initially we have how many students that have red hair? Initially we have 4, right? Because it's all these guys, 1 plus 2 plus 1, so 4. But then we're going to add a few students that have red hair. So that's basically the percentage at the end. And they're telling us that that percentage, they want us to make it 36%, so 0.36. So that's basically the equation we have to solve. So this shouldn't be that bad. Cross multiply, and we get 4 plus R is 7.2 plus 0.36 R. And then just do some algebra here. This is going to be 3.2. This is going to be 0.64 R. And then when you divide through, you will get R equals 5. So 5 is the number of students with red hair that must join the class so that the percentage of the students in the class with red hair becomes 36%. Number 2, an arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant d, called the common difference. For example, the sequence 2, 11, 20, 29, 38 is an arithmetic sequence with the 5 terms and a common difference of d equals 9. An arithmetic sequence has 3 terms. The 3 terms add up to 180. Determine the middle term. So we will call the terms a plus d, and a plus 2d. Right? That's basically how you would write the first 3 terms of an arithmetic sequence. And they're saying that these first 3 terms add to 180. So let's add them. And that's 180. Okay, so now let's do some algebra. So this is 3a plus 3d is equal to 180. Now, if you divide through by 3, you will get a plus d is equal to 60. Now in this question they're saying, what is the middle term? Well, this was the first, this was the second, and this was the third. So the middle term is a plus d, and a plus d is equal to 60. So that's basically how you do that. 60 is the correct answer to this question. B is the next one. An arithmetic sequence has 5 terms. The 5 terms add up to 180. Show that at least one of the 5 terms is equal to 36. So now we'll call the terms a plus d, a plus 2d, a plus 3d, and a plus 4d. And they're saying that the terms add up to 180, so let's add them. And they equal 180. So let's add these all up. So 1, 2, 3, 4, 5a, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10d. And I believe we can divide through by 5, and when we do, we get a plus 2d is equal to 36. Now they're saying show that at least one of these terms is equal to 36. Well, a plus 2d represents this term right here, which is the third term. And the third term is equal to 36, so we have proven that of those 5 terms, at least one is equal to 36. That's pretty much all that is. And part C, the arithmetic sequence now has 6 terms. The 6 terms add up to 180. Determine the sum of the first and the 6th terms. Okay, so first term, second term, third term, fourth term, fifth term, and 6th term finally. And then they're saying now you got to add them all up. And when you do, that sum is 180. Okay, so let's do the algebra, and this is going to be 6a plus 15d this time is equal to 180. I can divide through by 3, and when I do, I get 2a plus 5d is equal to 60. I think that's about as far as I can get. And then let's go back to the question, what do they want? The sum of the first and the 6th. So here's the first, and here's the 6th term. So those two terms would be a plus 5d, and their sum would be 2a plus 5d. Okay, well that's exactly what that is. And we have just found out that it equals 60. So that's pretty much all there is to that question. Triangle ABC has vertices A 0, 8, B 2, 0, and C 8, 0. Determine the equation of the line through B that cuts the area of ABC in half. Okay, so let's draw a little diagram here. It doesn't have to be a work of art, just to get an idea of what is happening. So the coordinates, let's see here, this one can be our 0, 8 right up here. We call that A. And then down here, similarly, we'll have a C, which is 8, 0. And then we've got a B, which is 2, 0. Okay, so our triangle is something like this, right? Yeah, like that. Okay, so what do they want? Determine the equation of the line through B that cuts the area of ABC in half. All right, so we can safely deduce that this point right here would be the midpoint. Right here would be the midpoint of AC, because if you have a triangle like this, and we want to cut the area in half, which is what they're saying, and this would therefore have to be the midpoint, because if this is equal to that, the heights will be the same. So 1/2 base times height here would be the same as 1/2 base times height here. So that's why that is M for midpoint. And to calculate the coordinates, that's fairly straightforward. You just use that and that. So 0 plus 8 over 2, and then 8 plus 0 over 2, and that's 4, 4. So the coordinates of M are 4, 4. And then now we just have to figure out the equation between B and M. So that's pretty straightforward. So we've got B is 2, 0, and M we just figured out was 4, 4. So the equation of a line is y equals mx plus b. The slope in this case would be, let's see here, 4 minus 0 over 4 minus 2, which is going to be 2. So therefore we have y is equal to 2x plus b. To figure out b, just substitute any of these guys. So when x is 2, y is 0. So that gives me b is equal to negative 4. So therefore my equation is y is equal to 2x minus 4. Now we turn our attention to part B. A vertical line intersects AC at R and BC at S, forming a triangle RSC. If the area of this triangle is 12.5, determine the coordinates of the point R. All right, so basically something similar but this time they're adding something else. So I'm not sure where this line is going to be, but I'll just take a stab at it. RS, probably something like this. Something like that would be my guess. That vertical line. Yeah. Okay, so as they say in the question, this is R up here, that point right here, and this is S right here. Okay, so they are telling me now that they want me to figure out the coordinates of R. Okay. So triangle RSC, that triangle, this is C right here, that point. They're saying the area is 12.5, so 1/2 base times height would be 12.5. So what is the base and what is the height? I'm going to have to give some coordinates here. S, I will call S0 in terms of the coordinates because it's on the x-axis. And R, I'm going to need to know the equation of this line, A to C. All right, and I think once I do that, it should be able to move forward with this question. So let's do that here. Let's move this up a little bit. So the equation from R to C, that's 0, 8, and 8, 0. So the slope is going to be 8 minus 0 over 0 minus 8, which is -1. And therefore, y is equal to -1x plus b. Substitute one of those guys, and when you do, you get b equal to 8. So the equation of line AC is y is equal to minus x plus 8. Right? Okay, good. Okay, so now we can fill in these guys. So 1/2 base. The base is from, the base is from here to here. So that looks to me like this 8 minus this s. 8 minus s. The height is from here to here. So that looks like basically the y coordinate of R. So since point R, this point right here, is on AC, which is y is equal to minus x plus 8, R would have the coordinates x minus x plus 8. And since S, this S right here, that value is the x coordinate of R right here, we can safely say that R is S minus S plus 8. So what goes here is basically the y coordinate of R, correct? Because we want to know what is the height. So that's going to be minus S plus 8. And I think that pretty much does the trick here, hopefully. All right, so let's expand this. We've got, let's see here, what do we have? First, let's get rid of that 2, make that 25. And then minus 8s plus 64 plus s squared minus 8s. So s squared minus 16s plus 39, I believe, equals 0. And then factor this. S 13, 3, minus, minus. I believe that works. So s is going to be either 3 or 13. Now, looking at this diagram, s is going to be between 2 and 8, so s is going to be 3. So therefore, R, this is R, right? Is that what we're trying to figure out? Determine the coordinates of R. Okay. So if that's what we're trying to figure out, we already figured out that S was 3, right? So that means the coordinates of R, 3, and then minus 3 plus 8 and 5. So there you go. That would be the answer. Part C of this question, a horizontal line intersects AB at T and AC at U, determine, forming A to U. If the area of A to U is 13.5, determine the equation of the horizontal line. Okay, so I'm gonna draw this again. Instead of making that diagram even more messier, let's just start all over. So again, we've got this time, doesn't have to be a work of art, but just to get a basic understanding of what's happening. Like that. So this was 0, 8, and that's A. And this was B, which is 2, 0. And this guy over here was C, 8, 0. And they're saying that this time we're drawing a horizontal line. And that horizontal line cuts through A, B, and AC. So something like this, something like that. And then they're saying that that becomes ATU. So this point, I guess, is T, this point, this U. And triangle ATU has an area of 13.5. And then what are they asking for? Determine the equation of that line. Okay, so the equation of this red line. All right, so, well, that's a horizontal line. So it's going to basically be of the form y is equal to some constant. Well, I don't want to use C. Let's just use K because it's horizontal, right? So X can be anything. All right, so how do we tackle this here? Okay, well, the equation of the area is 1/2 base times height. So 1/2 base, which I guess is from T to U, and then height, I'll just call it H for now. I don't want to introduce too many variables here. Well, they told me I can multiply through by 2, so 27. TU and then H. Okay. So I think I'm going to have to introduce some variables here in terms of the coordinates of T and U, but I'm going to need the equations of AB and AC. So line AB, I'm going to need the equation, and line AC, I'm going to need the equation. So that's easy to figure out. Y is equal to mx plus b. You guys have done this a million times. M would be 8 minus 0 over 0 minus 2, which is -4. So therefore y is minus 4x plus b. Substitute any of those points in to get the value for b. I'll substitute in 0, 8. And when I do, I get 8 equals to b. So this equation is y is equal to minus 4x plus 8. Yeah, that's the equation of line AB. Then in a very similar way, AC, M would be 8 minus 0 over 0 minus 8, which is -1. So therefore y is equal to minus x plus b. Again, substitute either of those points. And when you do, you get b is equal to 8. So therefore the equation of line AC is y is equal to minus x plus 8. Correct. Okay, so I needed that. The reason I needed that is because I needed to label this. So T, this T right here has coordinates. I'm going to use it letters. I don't want to get this. I don't want to use X for both T and U because that would be too confusing. So let's use A and B. Yeah. Okay, so this will be B, and the Y coordinate would be of the form minus 4B plus 8. That's the coordinates T. U is on this line, so that will be, I'll use A this time, and the Y coordinate would be minus A plus 8. Correct? Yeah. Okay, so that is so far so good. Now we can go back to this guy. So now TU is basically the distance from there to there. So that's basically A minus B. And then H is the distance from here to here, which I believe would be just 8 minus the Y coordinate. So 8 minus the Y coordinate, which is minus 4B plus 8. And I think that's good enough. Now, unfortunately, I got two variables in here. I got A and B, but I got to solve for one. So how do I do that? Well, keep in mind that the Y coordinates of T and U are the same. So this guy is the same as this. Why? Because it's a horizontal line. So that means that minus 4B plus 8 is the same as minus A plus 8. So that means that 4B is the same as A. And that's very helpful because now we can substitute that in over here. So 27, therefore, is going to be A is 4B and then minus B. And this one was 8. Remember, minus minus, so plus 4B minus 8. So I've got 27 is equal to 3B times 4B. Okay, hopefully I haven't made any mistakes. So that's going to be 27 over 12 is B squared. and therefore b looks to be like, well, that's 2.25, so if you take the square root, b would be 1.5. Okay, so that's good. Okay, so what do they want? They want the equation of the horizontal line. So we need to figure out the y-coordinate, this guy here. Is that right? Yeah. So the y-coordinate is minus 4b plus 8. Well, if b is 1.5, that's going to be minus 4 times 1.5 plus 8, which is 4.5 times 4, it's minus 6 plus 8, and that's 2. So therefore, the equation is y equals 2 of that horizontal line. For a solid right prism ABCDEF has a height of 16. Its bases are equilateral triangles, side lengths 12. X, Y, Z are midpoints of AC, BC, and DC. Determine the lengths of X, Y, YZ, and XZ. Okay. Well, several ways of doing this question, I think. I'm going to do the XZ first, because I think that's the easiest. I think that's just Pythagoras, because this is a right angle right here. I know it doesn't look like it, but it is. Because it's on. You're looking at it from an angle, but it's basically a rectangle. So, therefore, XZ would just be a Pythagorean relationship between XC and CZ. Yeah. And XC is going to be half of AC, and AC is basically 12. They told you it's equilateral, so that's going to be 6 squared. And then CZ is half of the full height, which is 16, so that's going to be 8 squared. So this basically means that XZ would be 100 square roots of 10. And then similarly, YZ would also be 10. So that's pretty straightforward there. XY, I believe, is going to be, well, it's going to be 6. It's going to be half, but I have to figure out how to explain that. Well, there's several ways. There's 30, 60, 90 triangles. Yeah, I think that's probably the easiest way. So let's just draw a bird's eye view of A, B, and C. And then you've got these midpoints, X and Y. And then this is 12. And then X is the midpoint, so this is 6 and this is 6. And since this is parallel to this, XYC is also equilateral. It's also equilateral, so therefore XY would be 6 and YC would be 6. Yeah, I think that's it. I mean, there's other ways of doing it, of course. You can talk about 30, 60, 90 triangles. You can use Pythagoras, but whatever way you want to use it, just as long as you explain it in words. I mean, I haven't written out everything. I'm just talking, but obviously on the exam you want to write it out because it's full solutions. Okay, so I think that completes A. So now let's talk about B. A part of the prism above is sliced off with straight cut through XYZ. Determine the surface area of solid CXYZ. Okay, CXYZ. Okay, I got it. Okay, so I guess we have 1, 2, 3, 4 triangles, right? So let me just do one at a time. First, let's just do XYZ. And I think I have the dimensions already, right? This is 6 and this is 10. And then if you draw the height, that's not drawn to scale, but that would be the height. Using Pythagoras, 6, well, actually it would be, this would be 3. So it would be 3 squared plus 8 squared is 10 squared. So H would be 100 minus 9, which is 91, so root 91. So the area, surface area, is calculating areas, of course, would be 1/2 base times height. So the base is 6 and the height is root 91. So that's 3 root 91. So that takes care of 1 of the 4 triangles, right? Yeah, 4 triangles. Okay, so the next triangle I can do, it doesn't really matter which way I go here. I can do XYC. X, Y, C. And again, same thing. X to Y is 6. And then XC was what? XC was 6? Yeah, I believe. So this guy is going to be 3, like just this distance. And then this is, you can easily figure this out by Pythagoras. 8 squared plus 3 squared is 6 squared. So that's going to be 8 squared is 36 minus 9 is 27. So h is 3 root 3. Is that right? Yes, I believe so. 3 root 3. So again, this area was going to be 1/2 base times height. So that's 9 root 3. Correct? Okay, so we got 3 root 3, we got 9 root 3. Now we just have to figure out the areas of XCZ and YCZ. Now these are both going to be the same because of the symmetry of the diagram. And I think that's very easy because it's just 1/2 base times height. And the base is XC and the height is CZ. Well, that should be pretty easy because XC is 6. Yeah, it's right here. That guy right there. And CZ was half of the, I actually have it here, it's half of the full height, so it's 8. So that's going to be 24. And then therefore, this is also 24. So now the full surface area, we've got this 3 root 91. We've got this 9 root 3. And then we've got XCZ, which is 24. And we have YCZ, which is also 24. And there you go. I think that pretty much does it. And that would be 48. So it's obviously mixed radical. Part C. The prism ABCDEF in part A is sliced with a straight cut through points M and P and Q on edges DE, DF, CB, and CA respectively. DM is 4, DN is 2, CQ is 8. Determine the volume of the solid QPC DMN. All right. So we got a few steps here. Let's go through this step by step. The first step is I'm going to concentrate on this triangle in the diagram that is M, D, and N. Now, they told me in the question that M to D is 4 and D to N is 2. And then notice that the question, if you remember, those were equilateral triangles. I think we'd have to go back and read the question part A, but those were equilateral triangles, so therefore, since they're equilateral, the angles, internal angles are 60 degrees. So in this diagram, it's this right here, that's 60 degrees. And those of you, hopefully, are experts on 30, 60, 90 triangles know that the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. And they have shown you that two of these sides have that ratio, and it's including the angle 60 degrees. Or you can use the cosine law to deduce, to figure out the length of MN. But I like to do it the faster way, which is, in this case, 30, 60, 90 triangle way, where this is 60, this is 90, and this is 30. So either way you want to do it is fine. I just like to save time. So that's the conclusion I came to by using the properties of 30, 60, 90 triangles, that MN is equal to 2 root 3. All right. So in a very similar way, now I will concentrate on the other triangle upstairs. That one is Q, C, and P. And they told me, I believe, that QC is 8. And also, that's also equilateral. So that's 60 degrees. And what else do I know here? Did they give me anything else? Well, I guess we just have to read the question a little bit more carefully, that this is a slice, right? Yeah, it's slice. Straight cut. So that means that the angles would be the same. So this angle would be the same as the angle that it eventually hits the bottom at. So therefore, we can conclude that this is also a 30, 60, 90 triangle. And therefore, this would be 30 degrees. And then based on the fact that you have a 2 to 1 to root 3 ratio, this would be 4, and this would be 4 root 3. All right. Well, that's pretty good, I think. Okay. So now, let's see here. Where do we move next? Well, I think where we should move is, I'm going to need some space here. So we will come back to all that stuff later, but we're going to need some space. What we need to do is we need to now concentrate on the shape. Now, when you're asked the volume, the first thing I think might confuse people is like, what is the volume formula? Because what is the shape? Well, it's a shape that has currently no actual volume formula, and that's what makes it challenging. So what we can do is make it into something that we can then work with. And what I'm going to do is I'm going to extend this, and hopefully it will therefore then resemble something that looks like a shape. And let's see if I can do this without... Alright, so I've extended it to make it look like a shape. And the shape that I'm really trying to create is a tetrahedron. Tetrahedron. And that's what that is all about, that extension there. Because eventually what we'll be able to do is calculate the volume of 2 tetrahedrons and then subtract them. And when you subtract them, then you'll get the shape that we want. Alright, so before we actually jump ahead and try to figure out the areas of those 2 tetrahedrons, first we need a few more values here. So let's just bear with me here. Let's fill in what we know so far. We know that's 4 root 3, right? We know this is 4. We know this is 8. Then we know that this is 4, this is 2, and that was 2 root 3. Yeah. And then I'm going to need to know some heights. Now, this I will draw sort of on this angle. I'm drawing Q, C, and I'm drawing M, N, and the very bottom, this point right here, I'll call R. And the reason I did that is because I'm going to need to know a couple more lengths. I need to know what is CN. Well, QC is 8, and this is a right angle, and this is 4. So by similar triangles, if you notice, triangle RDM, this is D. This is D. Sorry about that. That's D. Yeah. So RDM is similar to triangle RCQ. And that's helpful because that allows us to conclude that CD would be equal to 16. And therefore CR, well, that is going to be 32. So D to R is going to be 16. So that's a little bit of information I needed before I can proceed with the volume. Okay, so now finally we can proceed with the volume of the big shape that they want. And that is Q, P, C, D, M, N. Now to figure out that volume, we'd have to take the volume of the big tetrahedron, which I believe would be, if I were to, it would be Q, P, C as the base, and then going all the way to R. And I subtract from that the small tetrahedron, which would be, in terms of letters, M DNR. And if you do that, you'll get what remains, which is that weird shape that they want us to calculate the volume of. So the volume of a tetrahedron is 1/3 the area of the base times the height. So we got to do that for the big one, and we got to do it for the small one. Area of base times the height. Okay, I think that should be not a problem. So let's see here. The base for the big one is this right here. Right here. That guy, the QCP. So that's going to be, since this is a right angle, it would be 1/2 base, which is CP, which is 4. And then times height, which is QP, which is 4√3. Yeah, let me make sure that I'm doing this correctly. And then the height of the big one, the entire one, is going to be all the way from C to R, which is 32. Yeah. Okay, now the smaller tetrahedron, that base is this guy right here. So it's 1/2 base, which is 2 times height, 2√3. And then that height is 16. Yeah. Okay, so hopefully I have not made any mistakes. So this looks to me like 512√3 over 6 minus 64√3 over 6. And that is 448√3 over 6. And that reduces to 224√3 all over 3. And there you go. That is the volume of that shape.